Bismillahirrahmanirrahim. Assalamualaikum. Hi guys. Today our topic is about edge card and edge connectivity. Before this, we have seen the vertex card and vertex connectivity. So, a disconnecting set of edges of a graph G is a set of F subsets to E such that G minus F has more than one component. Okay. Okay. If we have a set of non-empty set S where T is subset to V for a graph G, we denoted as T. Then the set of edges having one endpoint S and the other in T. Okay. So what is an edge card? Okay. An edge card, okay, an edge card is of a graph G is an edge set of the form S where S is non-empty proper subset of V. Okay, in other words, edge card is a minimal disconnecting set. An edge card does not contain any other edge card as it is proper subset. Means that if the edge card is a proper subset, it not contains other edge that will cut the components into more than one set. Okay, and edge connectivity of G, edge connectivity we write as kappa prime G is the minimum size of an edge card. Why this is prime? If you remember, the vertex connectivity is kappa G. Okay, kappa G. Kappa G. Okay, this is edge, this is vertex connectivity. This is we have studied in the last lesson. Connectivity. Okay, so if we put kappa prime G means that it's not an edge vertex connectivity, it must be edge connectivity. So you can remember kappa G and kappa prime G. Kappa G vertex, kappa prime is the other side. Okay, that is edge connectivity. So K edge connected if every disconnecting set has at least K edges where K must less or equal than K prime G. An edge card with one element is called the cut edge or a bridge. So if edge card has only one element, it can sit as a bridge or cut edge. Okay, look at this example. The set of edges, if we have this set of edges, we say that set of edges AD, this is AD, CD, where is CD? This is CD, CE, and BE. Okay, if we cut these edges, so what will be the components left? Okay, if we cut there, so let we see here. Okay, when we cut here just now, okay, when we cut this, so that will appear this one, kan? Okay, now we have cut. Okay, this one, and this one have cut. So you will get this two components, 1 and 2 components. Okay, so we had also, so we said that this is the set of, this is an edge card. Okay, okay, is it there is also others edge cut in this graph where we can say that we see the graph of ADAC. Okay, if you cut AD, if you cut the graph of AD, AC, BC, and BE. So what graph do you get? So you will get the graph like this. Okay, A, B, okay, and then D, E, and F. Okay, so you have two components here when you cut the graph of AD, BC, AC, and BE. Okay, look at if you cut these edges. AD, you cut edges AD, okay, AD, AC, BC. So what is the graph that you will get? So if you cut these edges, you will get the graph like this. A, B, okay, and then you will get B, E, C, okay, sorry, D, and F. Okay, so you will get this also in two components. Okay, you can try for DE, CE, and DF. Okay, if we cut graph of DF, okay, DF only this you will cut. Okay, only this what edges we will cut. So what you will get? You will get one components and two components. Okay, so we say that the set of AD, CD, CE, DE. Okay, if we have a set of AD, okay, CD, CE. If you cut AD, CD, CE, it's have the graph have been disconnect into two components. Is it? Okay, there is two components already. But if you take another more DE, so we can say that A, D, C, D, C, D is a disconnecting set, but it not an edge cut. Why? Why this is not an edge cut? Because its proper subset is only this one, A, D, C, D, D, E. A, D, C, D, D, E is an edge cut. But if you put another one's D, E is not an edge cut already. Because it's enough if you cut A, D, C, D, and C, E only, it will disconnect the graph. Okay, it's set here as it said here. Okay, it's said here in this line here. It is not in any edge as its proper subset. Okay, minimal disconnecting set. You have to find the minimal disconnecting set. Okay. Okay. So if you cut DF, DF is only one cut edges. You will disconnect the graph. So we said that DF is an edge, is cut edge. Okay, the graph with cut edge DF, and its edge connectivity is 1. Edge connectivity is 1, so we say that kapal G equals to 1. Okay? Okay, H connectivity is kapal. You have to remember H connectivity is kapal prime G. Okay. Okay. Okay, let's see. This is the original graph. Okay, and if we delete the H here, okay, and also here, so you get 3 components. 1, 2, 3 components. Okay, this is a disconnecting set. Okay, and also we have if we but H cut, this is called a disconnecting set, but this is not an H cut, because H cut ni if you cut the edges, it give you the break. The graph will disconnect to 2 components. Okay, let's say the second graph here. So this is called cut edges. You only cut these edges, then it will break into 2 components. Okay, 1, 2 components, not 3. So this is called edge cut. Okay, this 3 cut is not an edge cut, because it actually, if you cut this one, you can disconnect the graph. Okay, that is disconnecting set and edge cut. Hope you understand. And if G is disconnected graph, K prime G equals to 0. If T is a 3, or K prime T, T is a 3, so K prime for the 3 is equals to 1. This is the formula that you must understand. Okay, and kappa prime for Kn is for the complete graph, is equals to n minus 1. So, are you sure? Let's say we draw K4. What is the graph of K4? Okay, K4. Okay, this is K4. Let's say this is A, B, C, and D. So, if we delete the graph of, so here you want to find K prime. Let's see, K4 we have 4 minus 1. So we found that kappa prime for K4 equals to 3. Okay, let's see either is it correct or not. So if you delete, okay, let's see. If you delete the graph 1, right? Okay, you delete the graph A, and then which graph I want to delete? The graph of this one, the edges, and then I delete these edges. So it means that I have delete 3 edges. So this is correct. Yeah. So it's proof that K4, you can use this formula to find the set of cut edges. Okay, for Cn, where n is greater or equal than 3, is equals to 2. Okay, Cn is graph of what? C is graph of circle. So let's say I have C4. Okay, C4. So if we want to connect the graph, so I can okay, we put y is cannot erase. Okay, erase this edges and erase these edges. So if you see here, we will get, okay, 2 components. So we delete 2 edges. Okay, so kappa prime equals to 2. Okay, so we can use, also is valid for formula of T, K, N and Cn. Okay, that's all for today for edge connectivity. Hopes that you will understand, and please don't forget to like this video and please subscribe. Okay, when you have seen this video, please put like. Okay, thank you very much. See you in the next topic.